what you found in here. So that's the parameters of your model that you should find. You don't have to define as many factors. You only need to define the factors that you really need. I had some extra ones here, but I think the only one that you have to define is X12 factor. You don't have to define the others, just I had them for free. You can do that this way. X7, X8 plus factor X12, X13, X14. And then you build your confusion matrix. Once you read the file and then you save the file under the same title that I had in my OS credit, and essentially, I mean, you can, I forgot the factor, that's not the proper one. There should be a factor here, so that's the one here. So that should be the one. So what you have to do is essentially plot your GLM. Your response variable is the variable y that you have in your data set. And for the other 5, if I'm not mistaken, X7 is quantitative, so you don't have to do anything. X8 is a true or false response, so you don't have to declare that one as a factor because R is going to handle that by default as a factor. X12 though, X12 has numerical values, numerical answers. So you're going to have to factor that variable. What you can do is you can factor it before or you can factor it right into your formula. Okay? You have 2 options of how to handle it. I think probably easier to do that within the formula. X13 and X14 are quantitative variables, so you don't have to worry about that. Essentially, you're going to fill your GLM using these variables. The data set will be my OS credit. The family is going to be binomial. And you should find below what I got. If you do that, you should find the following estimate that you get. There should be more. I need to drag it forward. That is the point estimate that you should get from your data. Okay, not all of them are useful, but you can see that probably, and again, that would be a separate step that we can take. We could simplify the model, and in fact, those that I've chosen are not necessarily those that are the most meaningful to make the prediction. You really have to do an exploratory which of the predictors has some impact on the response, being y equal 1 or y equal to 0. I didn't do that here. I just decided to pick some predictors at random. I picked 7, 8, 12, 13, and 14. And you can see that, I mean, x8 seems to be extremely useful, extremely significant. Factor x12, 3, so the third response of x12 seems to also be extremely important. Same thing for x14, extremely statistically significant predictor response. x7 is somewhat important. x13 somewhat less important. The factor 2 seems to be the less important of all, so probably factor 1 and 2. The response 1 and 2 for x12 would probably be grouped in one variable or one response. So did everybody found the same numerical values for the betas? After that, you can build a confusion matrix, and again, it's just borrowing the code that I have earlier. When you build your confusion matrix, this is the matrix that you should obtain. Okay, which, again, we're doing fairly well. You use the predict function, response type. If it's larger than 0.5, we're going to say it's a 1. If it's not larger than 0.5, we're going to allocate that to a 0, a false in that case. And then we just build a table that has the true response versus the prediction, or the prediction versus the true response. And what you can see is most of the elements are on the diagonal, but it's not perfect, as in any model. We don't get perfection here. So we get that most of the responses that were negative, y equal to 0, we were correctly identifying 302 out of 302 plus 81, so 383. As far as the positive response, when y is 1, we identify correctly 288 out of 288 plus 19 observations, so that would be 307. Okay, so the error rate in this case would be 19 plus 81 divided by 302 plus 81 plus 19 plus 288. An error rate of about 15%. Okay, so not bad, but obviously if there are predictive powers in the other variable predictors that I didn't use, then probably we should try to extract as much information as possible. I randomly chose 5 here, and some of them are meaningful, some of them are less meaningful, but obviously of the other, there was 14 variable, I picked 5, so there are still 9 variables that we haven't included in the model. So we can throw them all and see what stick to the wall. So you can do the exact same exercise if you want, but this time you can add up predictors. No? So for example, if you believe that possibly x1 is important, you can further that, include that variable here, and you can rerun the model and see how it does. But as you can see, x1 is not very meaningful. So adding x1 is not going to improve the confusion matrix whatsoever. It's going to keep it pretty much the same. Okay, but you can do testing. Maybe x2 is better. And adding x1. X2 is a quantitative variable, so we can add it straight up. X2 does not seem to be very important. How about x3? X3 is not important. How about x4? And x4 is a categorical that I need to declare as categorical. So I need to pass the factor. Well, x4 seems to be a little bit more meaningful because at least one of the categories that's important in the model. So once I include factor x4, hopefully it's going to improve my prediction. Not so much. It's about still in the same ballpark. And then you can do testing like that. I mean, I just did 5 variable. I mean, adding x4 factors seems to be somewhat meaningful. I mean, you can throw and see if you can include f5 as well as a factor. And see if you're going to improve in your prediction. x5 has a lot of categories, so it seems like you're improving the model as you include more predictors. No? But, I mean, of course, there is the idea of being of using a model that is parsimonious. So if you use in addition x4 and x5 in your model and you declare those variables as factor variable, so categorical, then you can see that your confusion matrix is improving. The number of misclassification that you make is smaller. So for example, I only get 60 false negative or false positive in this case rather than the other one. So you can improve the model this way. Okay? Are there any questions with the example? I mean, again, if you go back to the definition of the problem here, the y equal to 0 were related to decline. Application that were declined, and y equal to 1 were accepted applications. So in this particular context, what I would be more afraid is misclassifying a negative response. Because those are the applications that you should have rejected, and if your model is telling you to accept them, then essentially you're going to accept their application and you should have rejected them. Okay? So in that case, what you're concerned is the number in the lower part of your table. Okay? The lower left of your table, the 60 is the one that you're concerned. If you're concerned about that 60, what you want to do is increase the threshold. So to make a false response, you want to just increase the threshold of the positive response. So you're going to make less false prediction, or less true prediction, sorry. So in that case, what you probably want to do is increase this threshold to 0.7. And what's going to happen is when I'm going to increase it to 0.7, the 60 false positive will go down, will be lowered to a number of 28. Okay, so if you are concerned about misclassifying observation of type 0 as being, instead of being 0 as being 1, what you want to do is lower the 60 that appears in the lower end of your table, the lower left of your table. So drive up the threshold. Okay, because I don't want to accept those applications if, in theory, I should reject them, because there will be financial consequences in doing so. So what I'm claiming is here, you should probably, instead of using a threshold of 50%, increase the threshold to an amount larger than 50%, so you're not making as many errors. Okay, you're only making 28 errors here in terms of approving credit that should have been turned down, rather than the opposite that used to be 60. So you're correcting 32 of your mistakes by just increasing the threshold. Okay? But that comes at a price. Obviously, the 27 here is driven up to 70. But again, you're probably not as concerned about those, because those are applications that you should have accepted, but you just declined. So you turned down a customer that you should not have turned down. But that's part of the analysis that would come into finding the optimal threshold. So you want to find a threshold that is not too large, so you don't want to turn down a good customer. But on the flip side, you don't want to accept customer that should have been rejected. So by driving up the threshold, you're going to lower one error, and you're going to increase the other error. So you're going to have to find a comfort zone in fixing this threshold level at the end of the day. Okay. Are there any questions about
things up pretty much. What we did over the last, 2 days, we're using generalized linear models to predict both quantitative and categorical variables. So on the quantitative side, we really focus on the application of GLM in non-life insurance, in car insurance in particular. So we did the frequency, the severity models, and today a quick and dirty work on the prediction of categorical variables. But of course, it's simply an introduction. There's a lot more that can be built on the theory that we saw over the last 3 hours. But I think that wrapped things up. I hope you enjoyed the workshop. Hope you had fun. There's a lot of, there is also the second data set that we didn't go through that if by any chance you want to go through, there's, the code is available to you, so you can go online, download the code, and then take a look at the results that we got there. But it's very similar to what we did for data set 1 and 3. Okay. Yeah, so hopefully you enjoyed. I really enjoyed my time here. Very enthusiastic, so yeah, so I wish you all the best. There's a closing ceremony as well, so there's some diploma. Since you did pretty well, we'll distribute them. There's no final exam. Too bad. It's always better for the instructor to find out how much you guys really learn over the course of the workshop. So that's why. But I mean, it's more of a workshop and more for the sake of learning, I think, and getting to know a little bit the problematic, especially when you implement those things in R, because once you, theoretically everything is nice, no? But it's when you start getting your hands dirty and you try with data sets and you face some issues with those data sets that you really learn about techniques that work and techniques that don't work. How do you merge categorical variables so that you find a parsimonious model? I mean, we talked about that this morning. There's no perfect science. Often it comes with the expert opinion of the person like working with the model. But yeah, I mean, working with R really helps, I think, to learn this material. So I hope, for people that attended the short course by Professor Valdez earlier this month or in July, I think I probably put more perspective on things, because I heard that he did more of the theoretical aspect, but of course doing also the implementation is quite beneficial in those cases. There's a lot more that can be taught, but yeah, it was over a 2-day, so I wanted to keep things manageable, so I hope that I was able to accomplish that and at least give you a quick and dirty exposition on the concept of GLM application. Again, there's the 2 textbooks that I would strongly recommend. If you're interested in really applying those techniques, you should read a little bit further, not just what I presented, because it's just the preliminary material, but there is more in those textbooks. So if you want to use more advanced models or even try to understand more some statistical tests, I think there's more theory that are in the 2 textbooks, so you might want to read those textbooks as well. Otherwise, yeah, thanks a lot for bearing with me for 2 days. It was a pleasure. And then hopefully I'll be back longer next time. A week is not enough. I just finally got over the jet lag. I got a flight tomorrow night, so it's not good. But it was a fun time as usual. My 3rd time here, so I can't say that the flight is really pleasant. I don't sleep very well on planes, but when you're on the ground, I think it was a lot of fun. Like that working with you guys, yeah. So okay, so we're gonna probably moving on to the closing ceremony. I'm not sure. Thank you.
I just make it short. We come to the end of this workshop. Again, I'd like to thank all of you for this workshop. We have some of you are from industries and some of you are from academics. to apologize if there are any, and for me, I need to emphasize one thing that the Tamil event is one of our support to universities to reduce one-use plastic bottles. So I do hope that you use that bottle after this, so that it is not souvenir. So that next come can we follow what UGM initiative is. And also I would like to thank Professor Lendro for the present here. And the last part really remind me back to my time in Waterloo. I remember what the data set was like. Yes, the data sets, and I remember what when the assignment came. I remember that was in the deadline is just in Canada Day. And
July 1st.
July 1st. And it was I usually all Canada is actually the best. If you want to get best firework, just go in Canada. And then we went to Columbia Lakefront, and remember what we did? We bring our laptop there. So we are the only one who bring laptop in the party when we wait for the fireworks. And it wasn't done until the downcast. So when it's
10 o'clock. About 10.
no, like 9 or something when very before the fireworks. So we still working on that assignment. And I just gave up. Before the fireworks, just say it. As it is. And I say,
How was your mark? Was it a good mark or bad mark?
I think so.
It was good. It's a good memory.
Yeah. So when I saw here, this is Canada, always remind me that it's nice. Okay, that's all. Oh, okay. So we use. And on behalf of the Department of Permanent Students it's quite hard to find something that different because this is not his first time visit Indonesia. So I saw in his office a lot of staffs from Indonesia. I hope it's still unique from the others. So this is it. Thank you.
Awesome. Thank you. Awesome. That's good. That's good. That's going to remind me of my time here. Good memories. Thanks a lot. So do you want to call them and
Okay. Yeah.
so maybe you call them and then take
Oh,
yeah. There's a big chunk. There's a big chunk, yeah.
this is the gold gauge.
Exactly. It's like convocation at Waterloo. So
Yes.
Sekaligus aja fotonya bareng semua ya.
Okay, so.
Yang mau bandara
Udah.
udah.
Pak Dana.
Iya. Oke.
Sekretariat.
Shirley.